All right, so as I said, we will not have homework for Wednesday, and then we also will not have homework over Easter break. So you kind of get out of like, two for the price of one, I suppose. Okay, that doesn't mean you shouldn't still go back and review stuff. Um, we will not have in-person class on Wednesday, as I'll actually be sitting at an airport. I won't have flown out yet, but we will have some activity for Wednesday related to class. What I'll probably do, just to keep your time flexible, is I won't necessarily have it like due during the exact class period, but I'll probably put something up maybe like Tuesday night, and it's due by the end of the day on Wednesday. So some sort of quizzy, homeworky type thing, open book, whatever, but something to kind of, so it won't be a time stress thing. I'll probably give you, I might put like 2 hours on it or something like that, but something to kind of reinforce everything we've done up to this point, almost like in like a study preparation for the final, even though we're several weeks out from that, just, so relatively low stress, but kind of a forced review type of situation. All right, so I'll once I kind of decide on what that looks like, it'll be a quiz looking thing on Blackboard. I'll probably put 2 hour time limit on it or something, but it'll be designed to take something like 15, 20, 25 minutes. Not an epic adventure type thing, but I'll feel free to use iBooks or your notes or whatever. Just kind of a forced way to force you to review. All right, and you'll get a homework grade out of it. So it's a everybody wins type thing. Sound fair? All right. I tried to make the flight as late as possible. Just the only one I could take was coming out at 12:45, and with class ending at 11:55, it's going to be a rough rush to the to the airport. So I thought about doing class with Zoom from the airport, but whatever. American Airlines to Cabo.
That's not a Frontier.
Well, that's what was the cheapest flight. But since my wife's not, I always fly first class and my wife's not going. Otherwise, if my wife's going, I don't care if I spill into her seat. But every airline has their horror stories. There's people that would, this even goes back to like old computers, right? So before your time, one of the popular like budget brand computers was a company called Packard Bell. Okay, you can get a Packard Bell computer, and they were like if you went to like a Circuit City and bought a computer, that was your budget line PC. And there were people that said, "Oh, I'd never buy a Packard Bell. They were terrible. I never had anything but trouble." And you had people that said, they were the greatest thing ever. You get the same thing with cars, right? People say, "I'll never buy a Ford. I'll never buy a Chevy, or I'll never buy insert car company here because they've had nothing but problems with them." And then you have people on the other side of the coin that would never buy anything but that because they've always had great luck with them. So every time we do anything, every major purchase, we're just rolling the dice, hoping for the best. And frankly, anything with our computers, they're all coming off the assembly line in China or Korea or I guess actually now we're doing some manufacturing in India, which is kind of exciting actually. Because that's going to bring prices even down more. So now you have China and India competing for manufacturing rights for stuff. Okay, so what I want to talk about today. Well, first of all, how was the hackathon? Had a good experience? Okay. So yeah, I'm going to be reaching out to all the team leads and getting feedback. But so far, early feedback was all of the 200 folks did a solid job. I really liked the couple of teams that got the some of you involved in like writing your own screen or something like that. So even though it wasn't directly related to authentication, it gave you some, like a feeling of accomplishment for something. For the rest of you, if you did some shoulder surfing and kind of saw how working with an API and things like that worked, hopefully you got some experience that you recognize in 12 hours you got something that isn't really compatible with what you get in a class setting. So hopefully you see some value in that. Okay, so what I want to look at today So we have this function here called init, right? It's got underscore underscore before it, underscore underscore after it. What is this guy? What's this? What's this guy called? And what's his purpose? Go ahead. Okay, this is the constructor. Okay. All right. And what's the purpose of a constructor?
Good question. It kind of it allows certain like inputs to be used inside the class. And allows you to recall them later.
Okay, I'm pretty sure you know what it is. You're just having a trouble articulating it. But so by the name init is probably short for what? Initialize. So this initializes initialize. How do you spell initialize? Let's say you spell it right. Oh, I'm missing an I. Initializes. I can't see it all out of this eye. I didn't notice the eye was missing until I turned that way. Isn't that scary when you can't see out of one of your eyes? Yeah. Apparently it's common with the sinus stuff. It pushes on one of the sides of your brain and then that side just kind of shuts off, I guess. So this is what it is. I have to drive like this. You actually have to shut your eye, otherwise you can't convince yourself that it's not useful. You know, like it's not black. The world's blurry on this side, so I have to shut my eye and just turn that way, and then it's.
Why don't you get an iPad?
Well, I'm going to hopefully get an antibiotic that will solve the problem. Apparently, it goes away like in 24 hours when you're. I should wear an eye patch though, just for fashion. That's actually a good idea. I'm going to take you up on that. I already have my pink hard hat if you see me walking around campus with that. All right, so constructor initializes the starting state of an object. Okay, so we've seen that guy so far, but the part of this that I want to focus in on, just because we're going to learn a couple of other things here, is we have other methods that start with an underscore underscore, have some word in the middle, and end in an underscore underscore. So these are built-in methods for overriding default behaviors. All right, and let me kind of start at the baseline of this just so you kind of see what I'm talking about. What I'm going to do here is I actually want to put this guy kind of on hold for a little bit. So here, we're going to come up. I'm going to create another class up here. I'm going to create a class called person. All right, and just so this guy is technically legal, because if I just run it like this, I will actually let me. Yeah, we'll call it person. What is something that all persons have? I want to have like a. Well, I need a number associated with like for instance, pi is always 3.14159, right? I need something related to that with persons. I thought about just switching this to math. Number of fingers. I like that. All people have 5 fingers, right? All right. So I'm actually going to show you, we're going to talk about a couple of important concepts today, but they're kind of abstract concepts. They kind of fall into that category of like self, where they're a little bit rough to wrap your mind around, but just so this, I actually don't want to introduce this yet, but I need it in order to show you a class that's nothing but this. So we're going to say number of fingers is equal to 5. All right, this way, this is now a legal class. Otherwise, you can't have a class that has nothing in it. It'll yell at you and say that if you have something with like that, it's expecting at least one statement following it. So that class is illegal. You can't have a class that has nothing in it like that. Same thing with if statement. If you write an if statement and put nothing underneath it, it's going to say, what are you doing? All right. Notice that this guy does not have self dot in front of it. First of all, self doesn't exist yet because we only have those inside of our functions that are passing self around. But what this is saying is that this is a variable that's owned by the class itself, not instances of the class. So all persons have 5 fingers. So we've created a variable called number of fingers, and this applies to every single person, right? Now we're kind of forgetting about lawnmower incidents and, woodworking and various awesome things that will go onto the next soundboard, I'm sure. But yeah, but reasonably speaking, we can say that persons have number of fingers 5, number of legs 2, number of arms 2. These are things that, under normal genetics are not, they don't alter between people, right? All right, so, and let me show you what I mean by that. So I'm just going to come down here. I'm going to gut all of this stuff dealing with our dice bags. So all this stuff up here, I'm actually going to compress it all down just so it's not, see there's little arrows here so we can kind of hide a lot of this stuff. All right. So all that stuff's still there. I just kind of compressed it down because we're kind of ignoring this stuff right now. In fact, just so we don't have to scroll all the way up to the top, let me just take that there and we'll put it there at the bottom. So we can just focus down here. Okay. So if I go ahead and say P is equal to person, P2 is equal to person, and then I do a print P, actually what I would do, well, I think it'll run like this. Let me test this real quick before I explain it. Yeah. And I want to make sure that it doesn't run the other way. I expect this to give me an error. Yeah. See, that's one of the sucky things about Python, but we're going to pretend like that gives us an error. That has to do with how it handles instance versus class methods. Now, I made the argument here that this guy right here is a class variable as opposed to instance variables. Go ahead.
At a hackathon this weekend, everybody was kind of trashing on Python.
Okay.
Everyone was like, or at least everybody who was in the grades above us were like, yeah, Python kind of sucks.
Yeah, everybody said C# is better.
All right, here, let's just take care of that real quick.
Oh no.
no.
I assume everybody here wants to get a job.
Yeah.
Yes.
I mean, if I could just make money, that'd be cool, but like. Oh, okay.
Java, Python.
JavaScript for web stuff. See, I don't agree with Swift as number 2. That's if you're going to do iOS stuff. Java, C and C++. This would be back-end gaming stuff. Java would be like a huge percentage of your jobs are going to be Java-based. Giant percentage. Python, again, giant percentage, and going to be growing and moving forward because first of all, we have artificial intelligence, kind of a big thing, and specifically the field of machine learning and data analytics are 2 big things, and the primary tool for writing software for those is Python. Okay, and the thing is, it's not even so much that I'm a Python fanboy. I mean, I teach from the perspective that all the languages are the same, right? Okay, but Python is pretty important, and frankly, I don't even agree with C# being that high on the list. I think C# should even be lower on the list than that. The only reason C# is that high on the list is because if you're a game programmer, C# is the scripting language for Unity, which is a very, very popular tool. And it's not so much that C# is a poor language. C# and Java are basically the identical language. It all comes down to what's the right tool for the job. If you're writing C# code, you're either doing it for game programming or you're writing Microsoft-specific tools. which is fine. There's nothing wrong with that. You'll get paid big money doing C#. It's not a useless skill. It's a very important skill. In fact, I could maybe even make the argument that you have just as many opportunities open for Visual Studio .NET developer using C# as you might for Java. You're just going to be pigeonholed into writing business applications for Windows. Or Java maybe get you into some different, I guess, genre verticals for the types of software you'll be writing. Same thing with Python. You're probably not going to be going and writing business applications in Python. You'd be writing more back-end data analytics, artificial intelligence type stuff, which is going to be huge when you guys are getting ready to graduate, right? You're going to have top dollar jobs, and you're going to be looking, when you go to graduate, you're going to be seeing a bunch of jobs in Java because Java's platform independent. So it doesn't matter. People can write a single piece of software and have it run on every platform. And you're going to see tons of jobs that require Python because data analytics and machine learning are going to be very much mainstream by the time you're ready to graduate. And then you might see some surprise scripting languages kind of pop in there, like Google Go. It's kind of becoming kind of interesting, but you're going to see languages that kind of jump on that machine learning and data analytics bandwagon. I don't think Java is going to lose its shine for what it does. You don't have real competitors there. And C# again is a great language for what it does. It's married to Visual Studio, which is fine, Microsoft product. But if you're going to be writing C#, that means you're writing Windows applications, and there's a whole lot of people that use Windows. But you'd be writing products specifically for those people, where now we have a lot of cross-platform development where we're having stuff that's running on tablets and Chrome OS for those of you who have like Chromebooks or something like that. So now we're starting to move away from having a native operating system and towards something else. Okay, but what you should have done is probably slap the upperclassmen for even making a comparison between languages, because I definitely harp on that in here, right? That all the programming languages are the same. 100% of programming languages have facilities for remembering stuff, asking questions, and repetition. Python, Java, C#, they all come from C.
Maybe you should put that as.
They've all had it.
Well, no, maybe you should put that up for the students. It's like a general thing.
They've all had it. They all know that. What ends up happening is I think I even mentioned it like the first couple of weeks of class. As like a junior or senior, say, oh, well, I'm good at C#, but not really Java. And then it's because you get used to using a certain tool, and now all your problem solving kind of goes through the process of using that tool. And this has more to do with comfort with a tool than enjoyment of the language. Okay, so that's where things get lost. There's a lot of students who get frustrated with Android Studio. So for instance, most of the teams, you saw that, and this is actually kind of funny, almost an anti-Google statement. This last, at the hackathon, we're using Firebase, which funny enough is a Google product. Okay, they bought Firebase several years ago. And then Android Studio, which is also a Google product. So you're using the programming language Java, which is not Google's product, that came from Sun Microsystems, open source programming language, and you're using that inside of a development tool called Android Studio, using a third-party API for Firebase, which is built into Android Studio because the same company owns both of them. You would think those two things would work together seamlessly, wouldn't you? And what you have is both of them are moving targets, because Firebase is constantly being updated because Android uses as their core communication. All push notifications use Firebase. All data storage stuff use Firebase. That's Google's cloud, is Firebase. So that's constantly getting updates. Android Studio is constantly getting updates. When you're in class next semester, you'll see that every 15, 20 seconds there's an update to Android Studio. So every single time one of those two gets an update, which can happen like in the middle of the day, something will break. Because how many of you had that experience where something worked like at 10 a.m. and stopped working at 1 p.m.? And all of a sudden you had to change some number from like a 0 to a 1, in one of the Gradle files to get it to sync again. It's like stupid stuff like that. So you get frustrated with that as a tool until you get used to working with Android Studio and Firebase. So as soon as you get something weird like that, you spend 5 seconds going update the number for whatever updated in the background that you weren't aware of. And now you're back to the races. But that could be frustrating with a tool, where if you're doing Microsoft stuff and you're using Visual Studio and you're using Microsoft's database SQL Server and you're using Microsoft Cloud at Microsoft Azure, Everything works pretty seamlessly together. And Microsoft created those products, so you could see that being a less frustrating tool as long as you stay within the Microsoft ecosystem, right? Same thing over on the Apple side. As long as you're using Swift, which is an Apple language, and you're using Xcode, and you're writing software for one of their iOS devices, and you're using Apple's Apple doesn't really have a strong cloud presence, but whatever. You're staying in Apple's ecosystem. Things are nice, right? How many of you are iPhone users in here? Keep your hands up if you also have an Apple TV. I'm actually surprised that fell off like that. But maybe some of you had this experience. If you, how many of you have family members who have iPhones who also are on iOS, so you can use iMessage for talking with them conveniently, right? Okay, so that was the biggest change I had to make. I was on iPhone for 10 years because my software companies made a lot of stuff for iOS. And I wrote for iOS and Android on both sides, but iOS is where you really make the money, because you have more affluent users over on that side and whatever. So my whole family's still on iOS. My wife is still on iPhone, but I switched to Android Note 8 when I wasn't impressed with the iPhone X when they announced it. Well, the biggest hurdle for me was switching away from iMessage. All of a sudden, my mom needed my phone number. Right? Because before we just linked through the family account and she just messaged Mike, and that got to me magically through iMessage. So that was actually a substantial change for me. I also couldn't get as initially, here on campus with maybe poor cell signal unless you have Sprint. iMessage worked fine because it worked through the Wi-Fi, but text messaging didn't work until just this past year when the voice over IP on the phone started supporting SMS for that as well. So if I was in this room, I wouldn't be able to get a text message. Where before with iMessage, I could because that was being sent with data, not with the cell signal. So interesting stuff, I guess. Let's see who else was in here. Rust. That's a scripting language thingy. But yeah, Python's a pretty important language. It's not necessarily my favorite language by any stretch of the imagination. I'm not a fan necessarily of scripting languages. I like strongly typed languages like Java, C#, whatever, as a preferred medium, but you play the hand you're dealt, and Python's going to be an important thingy. All right, so we have this class here, and I've just given it this variable. I don't have self in front of it. What that means is that this variable is owned by the class called person, not individual instances of person. So P is a person. P2 is another person. So if I print out P and I print out P2, what will my output be for these two lines? We've covered this. Should we? Memory address. Okay, specifically different memory addresses, right? This guy's going to have his own memory address. This guy's going to have his own memory address. So we come back in here. These guys are different memory addresses. We have a 8D0 and a 940. We don't even have to look at the rest of it. Actually, the rest of it was the same. Different memory addresses though, right? Okay. So this is an instance of a person. It's one person. This is another person, just like you are a person and you are a different person. All right? But you both have 5 fingers, right? Because all persons have 5 fingers. The person object itself, not an instance of it, has a number of fingers that's 5. Now, technically, you saw me do it a few minutes ago. I can put P or P2 in front of this, and it will make it work because of the way the scripting language works. But I'm going to tell you from the way it's supposed to work perspective, because this guy is not defined with a self in front of it, it doesn't belong to individual instances of persons. It belongs to all persons. So it belongs to the class itself. So we would access variables like that using person, followed by the name of the thing. As opposed to if I had a and I were to print out p dot name, p2 dot name, and I passed in Dave and Mike, P's name would be Dave, P2's name would be Mike. So P has his own version of the name variable that's equal to Dave. Mike, P2, has his own name variable that's equal to Mike. And then person has a variable called 5, with a value called 5, and that's number of fingers. Make sense? All right. But if I were still printing out P or P2, we're still going to get memory addresses here, right? Okay. So now, what if I got rid of this init here? I purposely didn't have it in there before, right? It yells at me now because it's saying there is no constructor, that's really what this is saying, that takes a string as a parameter. I'm creating persons here, passing it a string. It's saying when I look in here, I don't see a constructor that takes 0 parameters. In fact, as humans, we look in there and say we don't see any constructors. But there is an invisible constructor there. Okay, we don't see it, but there's an invisible underscore underscore init underscore underscore that takes nothing and does nothing. All right, it's the default constructor that does the bare minimum that's required to set up this object, to make it an object. And if we don't choose to write a constructor, we still get that empty copy. But notice here, I'm trying to call my constructor and I'm trying to pass it a string, and it's screaming at me and saying, hey, you don't have one of those. The constructor takes no parameters. Okay? So if I come in here and I get rid of those 2 inputs, now we're calling that no argument constructor that we don't see in here, but that we can prove to ourselves does exist. It must be there, otherwise that line of syntax would not have worked. All right, and that's something that works across all object-oriented languages. The way it manifests might be a little bit different, but every object-oriented programming language will give you a constructor that takes no parameters and, from your perspective, does no real setup, other than the behind-the-scenes magic of going and asking for a memory address and all that stuff. So it does whatever the bare minimum is for generating an object. All right, so as a programmer, we actually don't have to write that init method, even though most of the time we're going to want to write that init method. And let me just prove, I'm 99% certain this isn't going to work, but just make sure that's the case. Yeah. So this guy expected an indented block after it and wants me to have some line of code following that guy. That's why I kind of had to introduce something here. I might have been able to do it with just a, can I do like, put a comment? I might be able to pull it off with a comment. Let's see. No, one's real stuff. So I could have put a different function in here. So I could have had like a def display self. And this guy just prints self, which is going to be his own memory address. So we'll go ahead and reinforce the idea of self versus this, since I know that's a kind of an abstract comment. So I created P, I created P2. We print out P, which prints out a memory address. If I then say print out, if I say P dot display, this will call P's version of the display method, and what it does is it prints out the value of self, which will be the same as the value of P. They're both pointers to the same place in memory. Self is how an object refers to itself from within itself. All right, so I declared P here, I printed P, then I asked P to display himself, and P's display method just printed out the value of self, which should be the same memory address. Similarly, I'll print out P2, which will be P2's memory address, and then if I say p2.display, that'll call his version of display, which will print out the value of his version of self, which will be the same memory address as what prints out in here. So these guys are the same. This is me printing out P, and this is me printing out self inside of P. So self is how an object refers to itself from within itself. This is me printing out P2. This is me printing out self inside of P2. Self is how an object refers to itself from within itself. Make sense? Okay. So I could pull off, we should have seen like a none. Yeah, it screamed at us for that last thing because it says there's no attribute called number of fingers because I took that code out. So now it's not going to yell anymore. Now we got real stuff. All right, so I didn't have to introduce that that class variable if I didn't want to, but you got to put something in here. I just wanted to make sure I didn't put an init in there to prove to you there is an init that comes with it if you don't do anything special. Okay? Now, what if, so I'm going to go ahead and take out this display thing. I'm going to introduce another. So these are anything with underscore, underscore, followed by something, followed by underscore, underscore. These are built-in methods that already exist for doing something. All right, I'm going to introduce kind of an important one. Let's call it our next important one. Underscore, underscore, str, underscore, underscore. This is the method that gets called when this object is printed. All right, and for those of you who have done Java before, or if you want to connect this to next semester, in Java, the equivalent is the toString method. And don't worry about, I'm not going to test you over that or anything, just that'll connect the dots to something we talk about next semester. All right, but just like we talked about self, and I said it's similar to this. Well, it's not similar. It's identical to the keyword this we'll talk about next semester. Underscore, underscore, str, underscore, underscore is the same as toString in Java. So that means when I print P here, what it's actually doing, we don't see it, but it's printing out P, str. Same output. All right, so this would kind of be inconvenient if we had to do that, but that's the method that's automatically getting called when we print something. All right, which means that if I want to not print memory addresses, I mean, printing out the memory address makes us feel all techie and stuff, right? Okay, it's like, yeah, this is cool. Okay, but the reality is, more times than not, we might want to be able to print a person and maybe it shows their first and last name, something like that. It gives us something real. It gives us what we initially started off guessing is what it would print out, right? We created our constructors. We said, oh, a person has a first name, a person has a last name, or a dice has a number of sides. Well, if I printed out an instance of dice, won't it just print out the number of sides? Not unless you write it to do that. The default is it gives you a memory address because his default underscore, underscore, str, underscore, underscore prints out memory address. Make sense? All right, so what that means here is, I'm just going to go ahead and get rid of this display now that I have something else I can write here. If I choose to write my own version of self, I can then return, I am a person, or something like that. I'll go ahead and just take this out since we proved that that's calling the same thing. So I wrote my own version of underscore, underscore, str, underscore, underscore, which overrides the one that I got by default. Just like when I write my own version of underscore, underscore, init, underscore, underscore, I'm overriding that default one. creating my own more specialized one because I'm doing something special here. Now, when I print P, it's going to print out I am a person. When I print P2, it's also going to say I am a person. Because at this point, I don't have a constructor that gives these guys anything to differentiate themselves from each other. All right, we'll add that here in a second. So now, this is me printing out P. This is me printing out P2. Or if I just change the name of this function. Now we're back to memory addresses because I didn't override that default one. That makes sense? So if we want to conveniently be able to print out our objects by just saying print, then an instance of an object, we have to override the str method, this guy, to have it print what we want it to print. Now, let's have this work in conjunction with our init method. So now we have a init that takes in a name, and then we say, we'll remind ourselves of our f strings. Remember that guy from last time? Yeah. So I am a person named, and this is self.name. So now our constructor takes in 2 parameters. In fact, let me show you this. Screaming at me now. It's saying, hey, you're calling this a init method, and this dude takes in a name. You haven't given it that. So when I chose to override it, when I said, here is what init for persons means, it's saying, we're not going to let you use the old one now. We won't provide you that no argument one because you've given your own. Make sense? It's actually a little bit more complicated than that. What's actually happening is the very first line of this is calling our parents constructor, which does the magical setup of giving it a memory address and doing all this stuff. The stuff that we don't have to worry about. This kind of comes back to like how languages are built. Okay. But since we don't see that, we can just say, look, we don't get the default one. We wrote our own, so it's gonna the default one isn't available to us. All right. So we have to give it a name. So I'll go ahead and say this is Dave. This is Mike. Dave's my little brother. All right. So now, when I print P and P2, it's going to say, I am a person named. For P, it'll be Dave. For P2, it'll be Mike. I am a person named Dave. I am a person named Mike. That makes sense? All right. So that's another method that we have access to is this __ string str method. Now let me pop open Zybooks here. I want to make sure there aren't other methods before we look at the less than, greater than, those methods. Because we can choose to allow us to compare persons to each other, maybe by age. All right, so this is in classes. Yeah, I think we're at the less than stuff now. So we'll just say more. So we have __ LT ___. We have LE, which is less than or equal to. GT is greater than. GE is greater than or equal to. Equal to, I think, is EQ. not equal to, I think, is NQ. I'm going to confirm that here in a second. Equal is EQ, not equal to is NE. Okay. I guess that makes sense. All right, any other ones it introduces? Okay, so less than, let's just use less than as an example. And I'm going to go ahead and we're going to put ages in here. So we're going to have a person taking a name and taking an age. And we'll just leave the string thing the way it is. So I'm going to say def underscore underscore LT underscore underscore. This guy's going to take in a self. And then we're going to call this other person. So this is comparing myself to some other person. All right. So now we can ask the question. We can say if self.age is less than other person.age, then return true, else return false. So I'm defining what less than means for these guys, right? So now if I print out, let me say, how old is my brother? I think he is 39. So if I print out P less than P2, I should get a true, right? It's true that P, who has an age of 39, is less than P2 with an age of 41. Called age. Oh, thank you. All right, so yeah, it's true that P is less than P2 because we overrode the LT function, right? But we did not override the GT function. So we might then say, okay, well, now I'm going to print P2 greater than P, which we happen to know that P2's age is greater than P's age, but we didn't write the GT function. Therefore, it's going to use the default GT function. And the default GT function just tries to do numerics, right? It's going to say, what is the value of P? It's a memory address. What's the value of P2? It's a memory address. Is P2's memory address bigger than P's memory address? It's probably going to give us an error because those memory addresses are actually represented as strings. Now you're saying which string is bigger. It might try to do some sort of Unicode comparison. I predict it's going to give us an error though. Nope, does a Unicode comparison. So let's say P greater than P2. So that should give us a false then. Yeah. So it's doing something with those memory addresses and comparing them as numerics or as Unicode values, but it's not comparing their ages. Okay? Not comparing their ages. If I wanted to compare the ages, I would write my own version of LT here. Now, we could have actually made this version of LT a lot shorter by just saying return whoever called this less than whoever they're comparing themselves to. Rather than saying if this is true, return true, if this is false, return false, I might as well just return this. Return the result of this math. Does that make sense? But if it makes you feel better to actually see the full drawn out logic, that's fine. If this is true, we're returning true. If this is false, we're returning false. If that is easier for you to read, so be it. All right, so questions about that? And similarly, you can go in, you can write things for less than or equal to, greater than or equal to, not equal to. So we have the ability to override all those. Yep.
The reason you can just put return and then the value is because it boils down to true or false.
Yeah, and it boils down to the same value. Yeah, so what I'm saying here, if this boils down to true, what are we returning? I'm returning the exact same value, true. If this boils down to false, what am I returning? False, which is the exact same value. So I might as well just return this value. That value boils down to true or false, and that result happens to be the identical value that I'm actually returning. I mean, if it was flipped, if I was returning a false in this case and a true in this case, then I could not just return this guy. I'd have to return not of that guy. All right, so makes sense how these underscore, these special methods are. These are kind of built into the language. You know, by putting an underscore before it and an underscore after it, it kind of says it's unlikely you're going to purposely name a method this. So we're going to kind of set those aside as our own method names, even though you could put minus under or underscore before and after your method names. Just if you happen to name it the same, they'll conflict with each other, and you're going to be overriding it. All right, so no homework for Wednesday. We will not meet in class on Wednesday, but I will have some exercise to do. That'll be due by the midnight on Wednesday or something like that. Remember, Easter break starts for you at classes after 4 p.m. that meet after 4 p.m. on Thursday. So any classes that meet earlier in the day on Thursday do meet. All right, go ahead.
The Wednesday thing, is that this Wednesday then?
This Wednesday, yeah, 2 days from now. The next time you will see me is a week from Wednesday because we're also off on Monday, right? Okay, so the next time you see me is 9 days from today, a week from Wednesday. So if you're traveling over Easter, have a safe trip. Don't do anything I wouldn't do, which leaves a whole lot on the table. All right.